talk about a couple things that we're going to do. So, on today we are going to look at the cell cycle and specialized cells. For homework, it is Friday. I'm not giving you any physical handout homework unless we do not finish our cancer study. If we don't finish that, then you will have homework. But you will need to study your notes because you will have a quiz on Tuesday with these things. What was my rule when you have any type of test?
Oh,
it was a rule now.
Promise rule. Read what? Read the question first and answer the question before you look at the choices. All right, so let's go ahead and get started. So remember, we separated into, yesterday we were all set up for specific groups so that we could actually, so we can actually see how cells actually go through the cell cycle. We were not able to get through a couple of, can you guys just move over just a little bit so I can see them back there? Tracy, stop playing with that Play-Doh. We were not able to get through all of them, all of the rounds, so that's why I'm putting us all together so we can get through as many rounds because there's a lot of things that we need to see with this. I need the extra talking to stop. Alrighty. So we dealt with 4 different types of cells. We have our blood cell, our liver cell, our nerve cell. What color was the blood cell? Red. Then we have our liver cell. That was what color? Blue? Okay. Okay, who's my liver cell? What group is my liver? Okay. Just look at the card and we can confirm it to what's right. Okay. Too much extra talking.
I'm just confirming what she said.
First of all, I didn't mention your name in specific. I just said too much extra talking. So our blood cell is red. Our liver cell is blue.
Yes.
We have our nerve cell, that's green. And our skin cell is yellow, and I'm just going to underline it with black because it's hard to see yellow. All right, so we're starting off with everyone, and everyone's going to have a chance, and every group member is going to have a chance to do some things. So we need to start off by having your clay as the size of a marble. Your marbles are not this big. No, just one group, one marble. It's not this big. A marble size, yesterday you all were giving me different sizes. This is a marble size. Sebastian, I don't need you talking right now unless you raise your hand and I've called on you. So you need to make a piece of clay this size. All right, so let's look at the procedures and the rules of what we should be doing. We should have your clay on the line in between where? Where should the clay be?
On the line between
G1 and M.
G1 and M. Which way are we going to go? Towards the M or towards G2? I'm sorry, towards S.
No, towards S.
We are going towards S because this is the what? This is called the what though? Cell cycle. And we don't get to mitosis until when?
Once we reach M.
Until the very
G.
end. Troy, I need you to move right here so I can keep a better close eye on you. Whose book bag is this? So we can move that out the way, please. Thank you. All right, so you have your clay there. We placed it where it needs to begin. Now we're going to begin round 1. We're going to start with, what do we say we're starting with? The blood cell?
Yes, us, yes.
Okay, so starting with the blood cell, you guys go ahead and roll your die. Where are we all starting? Once we enter into the cell cycle, where is that?
G1.
I don't want you to write anything. Where are we starting? G1, which stands for what? Gap 1. What happens during gap 1? This group over here.
Oh, cell growth.
Cell growth. What else happens during gap 1? This group over here. Antasia, why are you looking around? Look in your notes so you can be ready to help me. Make sure what? Say it again. I didn't hear you. Make sure the cell is healthy. All right, so we're starting in gap 1. So Blood cells. Roll the dice. What did it say? 7. What do you have to do? Start.
You have to, the body needs more blood cells. Grow by adding enough extra clay to your cells so that it increases to about 1.5 times its size at the beginning of G1. Then move to that stage.
Okay, so you're adding Play-Doh to your cell, and you're moving to that space. So what are we writing here? Well, what am I writing here?
But need more blood cells.
Do I need to put that?
More
Because
blood
that's not what happened to the cell.
Move to that
cells.
stage.
But what happened to the cell prior to move to that cell?
We added extra clay.
So cell growth. How many cells do you end up with now? Still 1. All right. We're going to move this way. You guys are next. Roll your die. And all of you can actually roll the die and be ready so we know when we get there.
Oh.
Roll the die.
What's your 7?
What are you guys?
Nerve cell.
Nerve cell. This is still round 1. Where are they starting? G1. All right. What number did you roll?
7. You are a nerve cell. You cannot divide. You enter GO permanently.
No division.
To continue, start over at the liver cell in the next round of the game. You're the liver cell key.
Okay, 1 second. No division. Go to G0 permanently. And then it says what?
We are liver cell.
To continue, start over your next round. And you are now a liver cell. Start next as liver. So you're going to use the same color, but now you're going to look at what?
Liver cell.
This group. You're going to use the same color Play-Doh, but you're now going to look at what key? Liver cell key for the next round. How many cells did you end up with?
2.
1.
No, 2.
Round 1.
Oh, never mind.
Yes. Alrighty. Moving on to this group back here. What are you guys?
Skin cells.
Skin cell. Where are you starting?
In the middle. Yeah, right here with the L.
Where y'all starting at, please?
He's telling you.
What's the actual phase? When the cell cycle starts, they don't say in the middle. Where do they enter into the cell cycle? Erica, you're looking at the wrong stuff. You should be looking at your notes. Where does the cell cycle begin?
Oh, anaphase.
It doesn't begin in anaphase. That's you're talking about mitosis. Where does the cell cycle begin? G1. Where are your notes?
Oh, okay.
And you were absent, so you need to get your notes for that.
No, I do have it.
All right. So, I'm sorry, this is round 1. And this is G1. All right, roll your dice. Did you guys roll? Make sure you guys make another cell and put it in the right spot. What did you guys roll? 10?
Yeah.
All right, what does it say? Okay, roll again.
7.
Okay, so now it says if you rolled a 2 to 8, which is a 7, the immune system has recognized and destroyed the cancer cell, which means that something was going on during what phase? G1. And the cell did what?
Destroyed it.
It checked, Simon, the cell checked for what? Make sure it's healthy. It recognized that it was not healthy, so then it did what? It destroyed not the cell, but it fixed it. Because it says it destroyed the cancer cell. Start over. Oh, actually, it didn't fix it. It destroyed that cell altogether. So you start over, and your next turn is G1 as a new skin stem cell in G1. So what happened?
We started over. As in
What happened to your cell, though?
it got destroyed.
Cell was destroyed. How many cells do you end up with?
None.
0. So make sure you make another cell. Use that one so you can start over your next round because it tells you.
Wait. I thought we still had that one cell.
Nope, it says we rolled a 7. The immune system recognized it and destroyed it. And then it says start over your next turn in G1. So if you want to smash that cell just so you can mentally know that it was destroyed, recreate a new one and put it in the right phase. All right, moving on to now our liver cell. Where are we starting, everyone? G1. Liver cell, roll the dice. 7. Read it to us.
The liver needs new cells grow by adding enough extra cells larger to about 1.5 times the size as
Okay, so to sum it up, what happened to your cell?
It grew.
Cell grew. And what?
It moved.
Move to what phase?
That's phase.
Move. Now I want to make sure you all realize your cell's not moving. It's just going through to the next phase. Just like you go from toddler years to your, you go from your infant to your toddler to your preteen to your teen. Well, you don't go from toddler to preteen. There's something else between adolescent years. How many cells do you have? How many cells do you have? But you don't physically move from the baby to the toddler. You just grow. All right. So now we're back at our blood cell. Blood cells. You're currently at the S phase. This is round 2. We're starting where?
The S phase.
S phase. Very good. Roll it.
I got 4.
4. And you're in S phase, so we need to be looking on our chart under S.
It says
Jenny, make sure you're looking down here.
your cell DNA replicates perfectly. Advance to G2.
Okay, so what happened?
Replication.
What replicated? Stop talking.
Cell.
The cell did not replicate. Reread that.
DNA.
DNA replicated. And what happened to the cell? Continue reading.
Advance to G2.
Okay. Move to G2. How many cells do you have?
2.
Look on your board. How many cells do you have right now? 1. All right, come on. Everybody roll so when you get over there, we already know what your number is.
12.
12? You can't get a 12?
You can't get
I know, I'm just joking. What are you guys again?
Liver.
Liver cell.
It says,
First, before we can move on, this is our second round. Where are you guys currently?
G0. I mean, no, G1.
No, you're not.
Yes, we are. That's not us.
They said they were the liver.
Yeah, we had to change.
Oh, yeah. My bad. I'm sorry. I apologize. My B.
You didn't have to cross out the 2 because you just not have the right.
You're right. My B. So now you are here. Where are you starting?
G1.
Wait.
G1.
And it says.
Hey, I'm sorry. This group back here, you have to be quiet. You're starting as a liver cell.
Yeah, and it says there was a DNA replication error. It cannot be repaired. Your cell awaits destruction. In the next round, start with a new liver cell.
Okay, so you need to do what?
Smush.
Destroy it.
Bye, guys. Here we go. Ugh.
And
0.
start over as new liver.
So we got 1 cell left.
Nope.
0.
Yeah, because we had.
That was when you were a nerve cell. You're not a nerve cell anymore. You're a liver cell. How many liver cells do you have?
9.
0. All right, moving on to now our skin cell.
We rolled a 7 and it said.
Where are you currently? Let me get it together first. Where are you currently?
We got destroyed.
So you're back at
G1.
G1.
And we rolled a 7, so it said we need to move to synthesis.
Wait, we need to read that beginning portion. Skin, the skin needs new cells. Then what? So what happened to the cell?
It grew.
Cell grew. And then what happened? Cell grew.
And then it moved to synthesis.
Okay. Move to S phase. How many cells do you have? 1. All right, liver cells. The original livers. Where are you? S phase. You rolled a 10 in the S phase.
It says there was a DNA replication error. Still one turn while errors on your next turn. Now roll.
Okay, so DNA is being repaired. And then next phase, you'll be where? G2 in round 3. How many cells do you have?
1.
1. So you're doing absolutely nothing right now. You're letting your cells repair. Moving back to our blood cell. Everybody roll. Come on, get up. You need to be everybody should be getting a chance to touch the Play-Doh and the dice. 5?
You want to touch some Play-Doh?
Well, let's go here, though. Where are you guys currently?
G2.
G2. You rolled a 5. What does it say, Vernon?
Oh, the body.
We on G2.
All is well.
Everybody else.
Cycling a protein and regulated process. Progress through the cell cycle is accumulated. Roll a little more by adding another bit of clay to a larger cell. To about 20
Speak up, Vernon.
At the beginning of G1.
So, cycling. What's cycling? You don't know. Read it.
Oh.
A protein and regulated process.
So, what's cycling?
Progress through the cell
It's a protein that regulates progress through the cell
That's
cycle.
right.
Vernon, what's cycling?
A protein that regulates progress through the cell cycle.
Okay, so why did you tell me you don't know? So, cyclin is a protein that helps with this whole growth of cells or the multiplication of cells. So, what's going to happen to you are you're growing a little more by adding another bit of clay, twice the size. So, what happened to your cell? It grew. And then you're entering into what?
Then we enter into the beginning of G1.
Really? That's not what it says. Read. Read it. Read it again. Read it again to make sure. No, Jenny, quiet. Read it again.
Right away. Roll again.
No. Go back to where you got G1 so you know exactly what that says.
Roll a little more by adding another bit of clay to enlarge your cell to about twice the size at the beginning of
Okay, so are you going to G1?
G1. No.
So what does G1 have to do with this?
Nothing.
No, be quiet. What does G1 have to do with this? It does. What is it saying about G1? Why is G1 there?
We just adding a little bit of piece of clay to it.
Okay, first of all, calm down. No, you're not. Second of all, you said something about G1 because it's there for a reason. And I need everybody to pay attention because you all do this. You'll see one thing and you'll just jump right to conclusions instead of going back and rereading and looking at it. And this is very important. So why is G1 there? Why does it say G1?
Oh, because cycling.
No, Vernon. Reread that sentence.
Roll a little bit more by adding a bit of
Quiet.
to enlarge your cells to about twice the size.
Keep going. You're not done.
At the beginning of G1.
So why is G1 written there?
Because we need to add more blood cells to it.
You're adding more clay, so it's going to be bigger than it was in what?
Then it was
Than it was in what phase?
oh, G2.
Your clay is going to be bigger than it was in what phase?
G1.
G1. So G1 is there to represent the fact that your cell grew, but it grew more, and it's going to be bigger than what it was the size in G1. This is important because you all will skip stuff and get it wrong just because you did not read correctly. So now we're entering into what, Vernon?
M.
M. How many cells do you have? 1. So your next phase that we'll be in will be an M, and that will be for round 4. Moving on to our formerly known as nerve cells, but now our the liver cells.
You rolled a 9.
You wrote a 9. This is 3. Where are we though?
We're at the beginning.
Which is what?
G1.
G1.
And it says the liver needs new cells. Grow by adding enough extra clay to your cells to enlarge it about 1.5 times its size at the beginning of G1. Move to the S phase.
Okay, so what happened to your cell? And
We're
sum
going
it up.
to enlarge it
Cell grew
and move to S phase.
and move to S phase. How many cells do you have?
1.
1. All right, we're now at the skin cell.
Yes.
All right.
We rolled a 7 again.
Okay, first of all, before we move on, this is round 3.
Yeah.
Where are you guys?
We had synthesis.
S phase, synthesis, very good. You wrote a 3?
7.
7, my bad.
It said your cell DNA replicates perfectly advanced in G2.
Okay, cells
Okay.
replicate, perfect.
Excuse me?
And then we go to what? So our next phase will be in G2, or our next round will be in G2. And we'll go from there. Moving on to our original lever.
We only have one cell.
Oh, yeah, my bad.
We got two.
No, you don't.
So this one that was right here.
That was a nerve cell. We're now looking at our liver cells. All right, yes. No, that was your turn. That you didn't do anything. You didn't move. You didn't do anything. So now we're at round 3. You're in G2 because it told you to go to G2 for your next turn. Read it out loud.
As is, all is well like a protein that regulates progress. Through this cell cycle has been completed.
Stop. What's cycling?
A protein that regulates progress through the cell cycle.
What's cycling, Erica? What's cycling?
It's
What's cycling, Bestie?
I think
What's cycling, Drika Scary?
the protein when the protein
Not when. What is cycling?
when
Not when. What
it's
is
a
cycling? It's a
protein-
noun.
It's a protein that regulates process through the cell
Through your
wall.
voice. Well,
thank you.
it's a protein that regulates what?
Progress.
Oh, progress. So cycling is a what? It's a
Progress.
cycling is not a progress. Come on, y'all.
A protein.
It's a protein that's very important for what?
It's regulating the process of through the cell cycle.
You don't need all them extra words. Cycling is a what? Protein that's important for what? Cell cycle. Thank you so much.
So
All right, Simon. It's still him.
Grow the more by another bit of place and part of cells without
Drika.
at the beginning of the
Okay, so wait, before you move further, what happened to your cell?
end.
Cell grew. And you're entering what?
Enter them right away in a row and as part of the same round.
Enter M. Okay, so as this round, you're entering M and as the same round. And now you need to roll again. Or, roll again as part of the same round.
We got 5. So,
But we're in M now.
so
You're
all-
5.
All is well, your cell chromosomes line up from the progress through mitosis and cycle.
Stop for a second. It says his cell chromosomes line up in the progress through mitosis and cytokinesis. What's mitosis again? Give me the beginning phase. Prophase. Metaphase. Anaphase. Telophase. And now we move through to cytokinesis. But how do we know that mitosis is complete?
Because you have two nuclei.
2 nuclei. Now we're moving into cytokinesis. That means we're going to have 2 what?
Daughter
2
cells.
new daughter cells. All right. So we entered M. It said that, where do you say? Number 5. Yep. Through the process of mitosis and cytokinesis, what's happening to your cell, Aaron? Read it. Read it. Read it loud. The first bullet.
Separate yourself.
I'm sorry. Wait 1 second so everybody can hear you. Go again.
Separate yourself with the 2 daughter cells by pinching.
Okay, stop. Do that. Cell pinches off to create 2 new daughter cells. Who remembers what daughter cells are called? The 2 new cells. What's another name for the Keelan? Diploids. Good job, Keelan. Catch your sucker, Keelan. Keelan, catch your lollipop. All right, Aaron. What else happens? What else are you doing?
Set one cell aside in your plastic cup where it remains. G0. Move the other cell forward to G1 where you start the next round.
Okay, so I didn't give you guys the plastic cups. I just didn't pass them around yet. So just hold it to the side. So how many cells do you end up with? 2. In round 4, you're going to start off again, and you're going to be where? G1. That's going to be with one of your daughter cells. All right, very good.
Wait.
Hold on 1 second. A lot happened with the liver cell that round, didn't it?
Yeah.
Miss Wiggins,
Of course.
when I had rolled that 12, I read out of the wrong place because we was only in G1. So do you want to just continue? Or?
Well, I'll wait till wait 1 second till we get to you all. We're about to be at blood cells again. So wait till I get to you all. All right, blood cells. This is our last round for blood cells.
Our liver be getting in.
We're at M, blood cells. Make sure we're looking at M. Roll the die.
6.
6. What does it say? Quatoria, read it out loud. Loud.
All is well, your cells chromosome line up, progress through mitosis and cycle.
So their cells also went through, what are the phases of mitosis?
Anaphase.
The metaphase is not a part of mitosis. Prophase, metaphase, anaphase, telophase. So they have 2 new
Daughter cells.
nuclei. Now cytokinesis, they have 2
Daughter cells.
daughter cells. Continue reading, Quatoria. Read loud, that first bullet.
Separate your cells, the 2 daughter cells, by pitching in half.
Do that now. 2 daughter cells created. Then you're going to set aside one of those cells. Oh, but yours says something different. It says set one cell aside in the plastic cup. So just put it in your other cup. Where it will differentiate into an adult blood cell. What does differentiate mean? Change. Move the other one to G1. How many cells do you end up with?
2.
2. Moving over to my misfits
Hey.
over here, who used to be nerve, but now they're livers because they're not happy with themselves.
Wow.
No, we just be getting it in.
Whoa.
Joy, be quiet. All right, so we're what now? Drinker, tell me what happened.
Okay, listen. So it says if you are in G1 or G0 enrolled. So we was in G1. And I read the one where it says if you are in S enrolled.
So you went from here to here. Well, okay, so we were here when you're talking about.
Yes.
Okay, so tell me what happened, what we should
I
have
was
done.
supposed to
Wait, you rolled a what?
12.
Okay.
The liver does not need new cells right now, but your cell has lost normal controls. Roll the number cube. If
Do
you
that
roll
now.
to-
Do it. So we'll fix this round and then we'll do that round.
I got a 3.
Okay, so if you rolled a 3, here we go.
The immune system has recognized and destroyed the cancer cell. On your next turn, start over in G as a new liver cell.
Okay, so then here,
We liver.
you still were
I mean,
destroyed.
yeah.
Okay, so you still were destroyed.
hmm
So you're still at 0. So it's fine. We're here, G1 cell group. We still can go with that. That's fine.
Okay, so
Okay.
now.
So now 4. You're in G1, Drika, remember.
Okay, no, I'm not. I'm in S now.
No, it said, Drika. It said start over your next size at G1. Because you got destroyed.
No, listen.
Oh, yeah, I'm sorry. My bad. I'm sorry. I apologize. So we're in S phase. You're right.
Okay, what I roll? An 8. Okay, I'm in S. So your cell's DNA replicates perfectly and moves to D2.
Okay, so DNA replicates. Move to G2. How many cells?
1.
1.
Can I go to the bathroom?
Yes. And then lastly, we got our last 2 are skin cell.
Yes, me.
Skin cell. You're at G2. Roll the die.
We got a 6.
A 6. What's 6 say?
All is well.
Stop. Put your paper down. Face down. Put your card face down. What is cyclin?
Cyclin is a protein that is needed during the cell cycle.
The cell cycle. It helps with the progress.
Oh.
Uh-huh.
Yeah.
All right. So cyclin is there. It's accumulated. What happens next?
We grew a little more.
Okay. Cell grew.
And, about 5 minutes side. Anyway, that's when
Okay.
we moved to M.
Okay.
So again,
1 second. Move to M. At the same time, roll the dice again.
We got another 6.
Another 6, but now we're in M.
Yeah, it said all is well. Your cell chromosomes line up and progress through mitosis and
Stop again. Phases of mitosis. Prophase.
Prophase.
Stop. What happens during metaphase?
Well, to the metaphase, they're
Meta.
They all line up in the middle.
What are they?
the
Chromosomes. Very good. All right. Metaphase. Anaphase. Telophase. What happens during telophase?
Two new nuclei.
Two new nuclei. This is the end of
Mitosis.
mitosis. We now have two new, also known as diploids. Very good. So, you guys then need to do what? Back there. What you need to do to your clay? Okay, so two new daughter cells form. How many cells do you end up with? Two. And then our original liver cell. It's okay because we're stopping at this round so we can move on.
So we won?
No, there's no winner to the game.
So,
You're at G1. Okay, what'd you roll? 10.
it says eliminate new cells, but your cells
I'm sorry. Stop for 1 second because everyone needs to hear this is a different scenario. Read it. Roger, read it because Simon reading real low today.
The liver needs new cells, but your cells are growing slowly right now. Skip one turn. On your next turn, do not roll the number cubes. Instead, grow by adding enough extra clay to your cells to enlarge it to about 1.5 times the size at the beginning of G1 and move to the S phase.
Okay, so basically, what happened at this phase? What happened in this round? It's growing slowly. So we can't do anything, right?
No.
How many cells do you end up with? Well, you still have 2 cells total. Any questions for this?
No.
All right, so I'm going to move this chart over to the side so that we still can see it. Because we're going to break some information down to get a better understanding. So when you're working on your cancer cell research portion that you have in front of you, you have an understanding of what it's asking for. So, with this information here, tell me some things that happen similar. Tell me some similar things that happen. Raise your hand and tell me. Cell growth that happened with all the cells. Amma, come over here and hold this other side.
All the cells, or just like it could be like 2 cells. Like they.
Did the blood cell grow?
Mm-hmm.
Did they grow?
Yeah.
Yes.
Okay. Did the liver cell grow?
Yes.
Thank you. Get the top part. Did the skin cell grow?
Oh, yeah.
Yes.
Okay. Did the nerve cell grow?
Yes.
Did it?
All of them did.
Cell group.
I think, but did all of them split?
Did all of them split? Good question, Erica. Did all of them split?
No, not the liver cell.
Not the liver cell.
Yeah, there's.
All right, so let's take a look at some stuff here. Where's my clicker? What are the different phases of the cell cycle? You got interphase,
And
mitosis,
cytokinesis.
and cytokinesis. Right?
Yes.
Good. Which was the shortest
Cytokinesis.
cytokinesis? Which was the longest?
Interphase.
Interphase. Everyone saw that?
Yes.
Everyone agreed?
Yes.
Okay. Which cells seem to divide the most? And I know that we didn't get a lot of division going on here, but let's base this information off of the cell that actually divided first.
The liver.
Wait, it was them. They tried it first.
Who did?
Liver divided first.
The liver divided first,
Yeah, I think so.
created 2 new daughter cells,
And then it was
blood and then skin. So we would say that the liver, skin, and the blood cells what would be the ones that would divide maybe the most. Definitely the liver and the blood. We continuously need blood. That makes sense?
Yes.
Our skin cells aren't dividing. They divide a lot because you damage your skin often. Remember, what are the reasons why we go through the cell cycle?
To,
Replenish.
get new.
Replenish,
Repair.
and grow. We're constantly growing as well. Which ones seem to divide the least?
The nerve cell.
The nerve cells. Which cells seem to divide the least or not at all?
The nerve cell.
The nerve cell. What conclusion could you make about this? And when I say what conclusion could you make, if you damage the nerve cell, then what?
It's done.
It's done.
Over.
Nerve cells do not replenish. They're done. That's why when people in sports have a spinal damage,
Oh, they
that's
get
their
stiff.
nerve. It's done.
So it's
That's why when people, how many of you ever gotten stitches?
Me,
How many of you who got stitches in an area where now you kind of, the feeling is a little different there now? Why do you think that is so? Nerves have been severed. This is where I got my surgery here, where I talked about before. This is very sensitive, and like the feeling is not there all the way. Like I have some sensation, but certain feeling is not there because there have been nerves that had to be cut, and they don't replace themselves.
Okay, I got a question. So, like, when my toe got cut open at the bottom, like, I don't have no feeling in that toe.
Nerves are done. All right,
What if
last
we-
question.
Wait, never mind.
Troy, go ahead. Last question.
now what if our nerves do regrow?
They don't.
No, I said what if they can?
Then you would feel it
That
afterwards.
means if we get paralyzed, we can get unparalyzed too, right?
Did anyone become a cancer cell?
No.
No.
No. But if they would have become a cancer cell, let's look at our cancer cell right here for a second, and let's just look at our skin cell. Well, actually, did anyone become a cancer cell?
No.
We did.
Yes, they did.
We did.
And what happened to the
We
cell?
got destroyed.
It got destroyed. It said it recognized it as a cancer cell and it destroyed it. So one thing that happened is it destroyed it. But let's take a look at your paper. Look at your actual card, not just the skin, and see if there's anywhere on there that states that the cancer cell can continue as a cancer cell. Take about 1 minute, look through your whole card, and see if there's anywhere that says continue as a cancer cell. Simon, what are you looking at? Liver. Okay, what phase? G1. What row? 12. Everybody quiet. What does it say?
It says if you roll 9 with those will get cells as will continue to the cell cycle simulation as a cancer cell activity.
Okay, so you have this as a cancer cell. So let's say as a cancer cell, now everyone look at their gray card as a cancer cell. And before we look at this, the skin cell also has it, where the skin cell says continue as a cancer cell as well. So the skin cell can turn into a cancer cell. Could the nerve cell? Who has nerve? Nerve cells, can you turn into a cancer cell? Nerve. Come on, Brandon. Read the card.
No.
No. Blood cell. Look at your card. Can you turn into a cancer cell?
Yes, we can.
What does it say?
It says if you roll 9.
What phase?
G1 or G0.
Okay.
It says if you roll 9 through 12, move yourself to 5. And continue through the cell cycle.
So stop right there. So we have our blood cell, our skin cell, and our liver cell can continue as a cancer cell. Let's look at our cancer cell. Looking at G1. Looking at the very first part in G1 or G0. Grow by adding extra clay. So could cancer cells grow?
Yes.
Yes. Can they move to the S phase? Move throughout the cell cycle?
Yes.
Yes, because it says move to the S phase. Let's look at the S phase. Your cell's DNA replicates perfectly. Advance all of the cancer cells to G2. Can they replicate DNA?
Yes.
It's going to happen with that replication as well. Remember, the whole purpose of the cell cycle is to create two new identical
So
cells.
it's gonna grow in their body.
It's going to the next cell is also going to be cancerous. Can we look at the S under rolling 10 or 11? It says there was DNA replication error. Skip one turn while repairs are made. Then advance your cancer cell to G2 phase. So it still repairs the DNA of the cell. Or it can say DNA replication error if we look at rolling 12, but all of your cancer cells continue to G2 without repairing it. So now you have damaged cells. If we look through, we're not going to read through all of it, but we can see that this cell is going to go all the way through mitosis, flip over to the back, all the way through to cytokinesis, which means that you're going to have a multiplication of cancer cells. Is that good?
No.
How fast do cells multiply? Is it this slow, as slow as we took here?
No, real fast.
No, right now you probably made billions of cells. And if those were cancerous, pray to God that they're not, then some person would have made billions of cancer cells as well. This is why it's so difficult to do what? Cure cancer. Because you can't eradicate all billions of cells. You've got to try to get to it really quickly. All right. Yes.
You know, when they do radiation, is that
Radiation is the burn. Yep. Yep. And so they want to do it continuously, but you can't do it all at once because you got all those cells. So you can't just knock out a whole bunch of cells. And that's why when people go to like chemotherapy and stuff like that, they're so tired afterward. They're so tired afterwards because that's damaging of cells. Think about if you were to cut yourself, that's a lot. Your body has to go through now remaking those cells. So in that process, your body needs energy. And you're drained of energy. That's why they're so tired afterwards. They don't feel so well.
So is that like with the people that like cut themselves that while they're like
Well, yeah, definitely. But despite the fact of emotional instability.
I know this might seem like a dumb question, but what makes cancer cells so bad? What does it do to the body?
They're damaged cells. Remember, your cells have to be identical. They have to have everything intact so that you can function and grow. Because you have skin cells, you have nerve cells. All of those things are going to grow as a part of cells into organs, into organisms, and things of that. So if they're not correct, then you're going to have malfunction of organs, malfunctions of organ systems. So yeah. All right. What are the important events that happen in each phase of the cell cycle? So let's go back. What happens during interphase, Kylie?
The cells grow.
Cells grow. What's something else important that happens during interphase, Rihanna? Make sure the cell is healthy. Jaleel, what is something that happens in the cell in interphase? Where your nose? Jenny? Replicates organelles. Anything else? It copies DNA. Very good. Once we move through this very long process, you have more cell growth. You then enter into what, Antasia?
The prophase.
Antasia.
My bad.
What do you then enter? From interphase, what do you then enter? Wait. From interphase, what do you then enter? This is interphase. Where do we now enter? What is this? What are you reading? Hello. Mitosis. We enter into mitosis. Mitosis is broken down into how many phases?
4 phases.
4 phases. What is the first phase of mitosis? Come on. Where you know? Come on now. Ask a friend right now. Ask a friend. Come on.
Prophase.
What phase? Prophase. Troy wants to talk so badly. What happens during prophase, Troy?
It's the beginning.
But what happens?
The nucleus dissolves.
The what?
Dissolves.
Dissolves. What does that mean, the nucleus dissolves?
It
It starts to disappear. Why is the nucleus dissolving?
So the chromosomes.
So the chromosomes can what?
Be in the middle. Line in the middle.
Move freely. Begin to
replicate?
Replicate. Very good. Which leads us to our next phase. We have prophase. Then we have metaphase. Is that true?
Yes.
Yes, that is true.
What happens during metaphase?
All the chromosomes line up in the
All of the chromosomes line up in the middle, hence meta, M. They're lining up in the middle because they're preparing to do what, Roger? Separate. During what phase, Bessie? During what phase are the chromosomes going to separate? Anaphase, separation. Then we're going to move on to what, Mesa? Telophase. What happens during telophase? Aaron. Telophase. Hush. Two new nuclei. Good. Very, very, very good. This is the end of Bacteria. Oh, Bacteria, you got a lot of voices. Scary. Mitosis. Because we have two new nuclei. Are we done with the cell cycle?
No.
Then we need to move to baby.
Splitting cells.
Cytokinesis, which is the Troy.
Splitting cells.
Splitting of the cells. Are we done with the cell cycle?
No.
Yes.
Why? Two
Cells.
new daughter cells, also known as. Okay, quiet. What is the protein that is responsible for this process?
Cycling.
Cycling. All right, very good. What kind of things can go wrong? Unhealthy cells. So then they would do what?
Create cancer cells.
Well, what would your cell possibly do?
Become abnormal.
It could continue to duplicate that and be abnormal, or it could destroy the cell. Very good. Yes. Yes. All right. So we talked about this briefly. How are the cells different when you came to the cell cycle? Your nerve cell what? Your nerve cell what? They don't replicate at all. Your liver cell, do they replicate?
Yeah.
They did replicate. Sometimes it was slower because some DNA had to repair. What about your skin cell?
Yes, it does.
Yes, it replicated. What about your blood cells? Yes, it did replicate as well. All right, so here's the synopsis, and I'm going to lead you on to doing your cancer paper. Your nerve cells, they never grew, they never reproduced, and they stayed in G0 phase. Once they specialized into a nerve cell after you were born, when you were born, you started getting nerve cells right away. So you have feeling right as an embryo.
Wait, I'm sorry.
Okay, hold that thought because I know we're going with that 1 second. Then you move on. Then you have specialized cells. After that, your nerve cells never grow anymore. Then your liver cells, they could get destroyed. They don't reproduce very much, and they had a hard time growing. Your skin cells reproduce frequently. They move fast through the cell cycle, and they could have problems in mitosis. And then your blood cells, they grow, they replicate DNA, they divide, they never stop replicating. They are considered to be the healthiest, and they're the most active. I'll wait till we get started, then I'm going to ask you something separately. Any questions about this in general?
No, but I got a connection.
Okay, 1 second. All right, then what we're going to do right now, you have your cancer, what did I title it? Cancer case study
Yeah.
in front of you. We're going to look at our cancer case study. You're going to be reading that. This is page 67. I'm just going to pull it up really quickly. This is real information. This is not simulated information. So you and your group are going to read through the cancer case study. And then on the last page, you will know that there are questions. Notice that there are questions. Analyzing the information that you read. And also, it is bringing in what we just did as a simulated cell, Erica.